Hi everybody, welcome back for note 6.6. In this lesson, we're going to be talking about solving rational equations.
Okay, let's look at our first example. Solve 2 over x plus 3 plus 1 over x equals 6 over x times x plus 3. All right, so first thing we check is, are there any denominators that need to be factored? I'm looking at all of them, and I'm going to say no. Now, the next thing I need to find is, what is my LCD? So if I look, I've got x plus 3, and I've got them over here, so it's a single x plus 3, and then I've got an x, and then an x. So basically, x plus 3 and x, that's going to be your common denominator. So now, here's where the road can diverge into two separate paths. There are two ways to solve rational equations. The first way is called clearing the fractions, and that's what we're about to demonstrate here. The second way is to do what we did in the last class and multiply top and bottom by what we're missing of the LCD and then squishing the fractions together. So I'm going to show you clearing the fractions first. Now here's the catch about clearing the fractions. This only works when it's an equation. You cannot use this or do this when it's an expression. If it's a fraction plus a fraction and there's no equal signs and we're saying simplify, you have to multiply by what you're missing out of the LCD. However, an equation, we have two different ways. Now, I'm not going to dictate which way you have to use. You can do it this way or you can do it the other way. It doesn't matter. Okay, you just have to pick the method that works the best for you. So let's move on with clearing fractions. So they want us to solve, so we know our LCD is equal to x times x plus 3. So what we're going to do is we're going to multiply every term by x times x plus 3 over 1. Always multiply it by 1 so you have a denominator. Now, you're like, well, how does that make sense? Because when we did LCDs, we multiplied by what we're missing. Yes. However, think about an equation. If I multiply every term by 3, it's still going to reduce to be the same equation. So as long as you multiply each of the terms by the same thing, you still keep the fact that those fractions equal the other fraction on the other side. So let's look. So we're going to multiply by x times x plus 3, x times x plus 3, x times x plus 3. Now, here's the catch. You're going to cross out. So the idea of clearing the fractions is to clear the denominator and get rid of the denominator. So in this first pair, x plus 3's cancel. In the second pair, x's cancel. And then lastly, on the third fraction, everything cancels. So now we are going to squish together into an equation, combine like terms. What's left? So we've got 2x, we've got 1 times x, 1 times 3, and then 6 is by himself. All right, so let's write what we have left. I have 2x, and then remember, I have x plus 3, because that's what you get when you multiply it by 1. And then we have 6 left on the other side. Now, once we've done this, all we have to do is combine like terms and solve. So that gets me 3x plus 3 equals 6. Now I just have to solve. Well, how do I undo addition by 3? I got to subtract 3 from both sides. So I get 3x equals 3. Then I have to divide by 3. So I get x equals 1. Woohoo! But don't rejoice yet, because you have to check for reasonableness. Now, what reasonableness is basically you're finding the variable restrictions and you're making sure that your answer is not part of the variable restrictions, okay? So looking up here, you can really look at your LCD. It'll tell you. So I have 0 for x right there, and I have -3 for x right there. So my domain restrictions are 0 and -3. Well, I didn't see anything about a 1 in there, so 1 works because it's not part of what x cannot equal. So we write our solution. X equals 1. Okay, look at another one. Solve the rational equation. Excellent. Okay, now remember what I said on the last one. The first thing before you do anything is you've got to see, do my denominators factor? So I know that something times something gives me 2 and also adds to 3. And that's, this guy's already factored. Well, he's not really already factored there, it just doesn't factor. And same with x plus 1. So I need to factor that left rational expression. So I get x minus 1 over x plus 2 x plus 1 plus 2 over x plus 2 equals x minus 1 times x plus 1. Now, we are going to get the LCD. Well, if you look right here, okay, x plus 2 x plus 1 already takes into account these guys, okay? So, my LCD is going to be x plus 2 times x plus 1. Now, what we're going to do one more example of clearing the fractions. So, that means I'm going to multiply each term by the LCD over 1. So, x plus 2 times x plus 1 over 1 to each term. Now, let's see if anything cancels. Well, in the left fraction, the x plus 2's cancel, and so do the x plus 1's. In the second fraction, x plus 2's cancel. And then on the right side of the equal sign, the x plus 1's cancel. Now, let's write what I have left. Okay, so let's write what we have left. In the left rational expression, I should just have x minus 1. And then in the second fraction, I have 2x times x plus 1. And then in the third rational expression, I have x minus 1 times x plus 2. So now we have to clean this up. Notice all of our denominators are going away. So I'm going to take and distribute this 2x to x plus 1. And then I'm going to FOIL. See if I can write it here. I'm going to FOIL that guy. Okay, so 2x times x plus 1 is 2x squared plus 2x. And then when we FOIL the right side, we get x squared, x squared plus x minus 2. So that's how I got that. Now I still have some combining like terms to do with the x minus 1 and the 2x squared plus 2x. So that gets me 2x squared plus 3x minus 1 equals x squared plus x minus 2. Now, this is a quadratic. So the only way to solve a quadratic is to make it equal 0. That's always your first step. So I'm going to bring the x squared over, I'm going to bring the x over, and I'm going to bring the minus 2 over. So I'm going to subtract x from both sides. I'm going to subtract, I'm going to subtract x squared from both sides. Then I'm going to subtract x from both sides, and then I'm going to add 2 to both sides. So you know this trick. It's just setting it equal to 0. So now, if you can't factor this, you are always welcome to use the quadratic formula. But a lot of these will factor, and it just makes it easier. So x squared plus 2x plus 1 factors to be x plus 1 times x plus 1. Then I set them equal to 0. Well, they're the same factors, so I get x is equal to -1. But remember, we need to check and see if it is in the domain or the variable restrictions. Well, I see right here that x can't be -2 and it can't be -1. Wah, wah. He's a variable restriction. So, therefore, no solution. I know it's frustrating. You do all this work and you're like, oh my goodness, now it's in the domain restriction. It doesn't work. All that work for a no solution. But that's what we want to see. So again, if your answer is in the domain restriction or the variable restriction, it's a no-go. It doesn't work. All right, last example.
Let's look at another way to solve a rational equation. In this method, we are going to get each term to be over the common denominator. So what I look at here is I need to look at my denominators. So I see x minus 2, I see x minus 4. Well, neither one of those can be factored. However, I have a quadratic trinomial here, so I need to factor that denominator. And when I do, that denominator factors into x minus 2 times x minus 4. So looking at this, I'm like, well, x minus 2, going to need that. X minus 4, I'm going to need that. And this one already has the common denominator. So that tells me that my LCD is x minus 2 times x minus 4. Now I'm going to work at making sure each term has the common denominator. So I'm going to multiply each numerator by the missing term from the LCD. So this is just like what we did on day 6.5. So looking at x over x minus 2, looking at x over x minus 2, I see that I'm missing x minus 4. So I'm going to multiply that term by x minus 4 over x minus 4. Looking at the second term, 1 over x minus 4. I see that I am missing x minus 2, so I'm going to multiply the numerator and denominator by x minus 2. Looking at the term on the opposite side of the equal sign, it has both elements of the common denominator, so it doesn't need to be multiplied by anything. Okay, so now what I'm going to do is I need to clean up that numerator. So I'm going to take and distribute the x to the x minus 4, and then I'm going to distribute the 1 to the x and the minus 2. So the first term becomes x squared minus 4x. The next term becomes x minus 2 over x minus 2 times x minus 4. And then this other one on the other side of the equal sign stayed the same. Now you may wonder, well, should I multiply those denominators together? The answer is no. You don't need to, and you're going to see why here in just a second. So save yourself the headache. Only worry about the numerators, and you can keep the denominators factored. So now I'm going to combine like terms on the left side of the equal sign. So I get x squared, and then I can combine negative 4x with x to get negative 3x. So I combine terms on the left, and then of course just bring down the right side. Now, if you note, my denominators are now the same. So if the fractions are equal, and the denominators are the same, you can totally forget about the denominators now and just set the numerators equal, because the fractions are equal and the denominators are the same, so therefore the numerator should be the same too. So I do x squared minus 3x minus 2 equals 2. Now, this is a quadratic trinomial. So this is a quadratic trinomial, which means to factor a quadratic trinomial, it needs to equal 0. So I'm going to bring that 2 over to the left by subtracting 2 from both sides, and that becomes x squared minus 3x minus 4. Now it's time to factor. I need two numbers that multiply to make negative 4, but also add to make negative 3. So negative 4, positive 1. Now I take each factor and I set it equal to 0. So x minus 4 equals 0 is x is 4. x plus 1 equals 0 is x is negative 1. So I have my two solutions. But we can't stop there because we have to check and see, are our solutions part of the domain restriction? So I go up here, and basically my LCD is the common denominator all the way down. So I look and I say, well, that tells me that x can't be 2. So we're good there. And then this guy tells me that x can't be 4. Uh-oh. So x minus 4, or excuse me, x equals 4 does not work. So our only solution is x equals negative 1, because x equals 4 is part of the domain restriction.
Okay, let's look at this word problem. It says Adam and Brian own A and B painting. Working by himself, Adam can paint a 2,000 square foot house in 6 days, which is 48 hours. By himself, Brian can paint the same house in 5 days, which is 40 hours. If they were to join forces and paint the house together, exactly how long would it take? Now, the fact that it says exactly, that means we're going to, if it's a fraction, we're going to leave it a fraction. But let's get rid of some non-important information, like 48 hours, okay? 48 hours and 40 hours. The only thing that's telling me is that they're both working 8-hour days, okay? That's all that's telling me, is that they are working 8-hour days. So in other words, one person is not working any longer than the other. They're both only working 8-hour days. The other thing we can cross out is the fact that the house is 2,000 square feet. If they are painting the same house, it doesn't matter the square footage. The equation will take care of it. All right, so we do have some key information we need here. We have Adam, and he takes 6 days. And then we have Brian, and he has 5 days. So now we're going to fill out these little sentences here. Okay, so let's think about this. If Adam can paint one house in 6 days, one house in 6 days, how much of the house can he paint in 1 day? So one house, 6 days, it stands to reason that if we took 1 day, he would be able to paint 1/6 of the house in 1 day. Let's look at Brian. Brian can paint the same house in 5 days. So it's going to take him 5 days to paint this house. How much of the house is he painting per day? And that's 1/5. Okay, so these two numbers right here, 1/6 and 1/5, those are their rates that they are painting per day. So that leads us to this next equation. Okay, if I take 1/6, this time we're gonna let D equal the number of days they paint together. So I take his rate times the number of days, and then I take Brian's rate times the number of days. So if I take their rate times the days plus their rate times the days, that should equal one whole house. Okay? So now what we have to do is we need to solve this. But to solve this, we've got to do something with the common denominator. So what is the common denominator of 6 and 5? Ding, ding, ding. It's 30. So we are going to multiply each of the terms by 30. So we're using that clearing the fraction method on this one. You could also multiply by what you're missing, get common denominators, and solve it that way. Okay, I'm going to do clearing the fraction. So that means I'm getting rid of the fractions, which means I need to multiply each term by the LCD. Well, 1/6 of 30 is 5. 1/5 of 30 is 6. So I get 5D plus 6D equals 30. Now, combine like terms. we get 11D equals 30. And then we divide by 11, and we get 2 8/11 days. Okay, now we said exactly. So you could leave your answer in fraction form like this because that tells me exactly how long it's going to take the painters to paint the house. Now, talking in terms of the real world though, if you were Adam and Brian and you were painting this house, you probably wouldn't go, it's going to take me 2 8/11 days. Because the customer's going to look at you like, what? Huh? You'd probably go ahead and say 3 days. That way, you know, you'd have a little extra time. But because this question said exactly, we don't want you rounding up to 3. We want it as a mixed fraction. Okay? All right. So that's this one. This type of problem is called share the work. That's just because they're sharing the work. But that's if you ever hear us refer to it, that's what we call it, a share the work problem. All right, let's look at another one. Okay, let's look at our next example. A basketball player has made 18 out of 30 free throws this season. This gives her a 60% success rate. If she wants to increase her success rate to 80%, how many consecutive free throws must she make? Okay, now, if you remember back to your week 1 homework, you had a problem like this on your homework, except it was soccer. So, same idea, but I think you're gonna understand it even better after you see this explanation of it. Okay, so to get her 60% success rate, you took the number of shots she made and you divided it by the number of free throws she attempted. Okay, so you're gonna take the number she made and you're gonna divide it by the number that she attempted, and that's gonna give you a decimal. And then you'd multiply that decimal by 100 to get her success rate. So that's exactly what they did to get her 60% success rate. They did 80 divided by 30 times 100, and that gave her 60%. But here's the deal. If we need to increase the number of shots she makes, we're also going to have to increase the number of shots she takes or attempts. Okay, we already know she's already made 18 out of 30. That's in the past. That's information we're working off of, but we cannot change that. But if we add the number of shots she makes, we have to add the number of shots she takes or attempts. And we're going to let X be the number of shots that she makes, which means that it would also increase the number of shots she takes. So I add X because it's got to be the same amount. I add X to the top and the bottom. Now, what we're going to do is we are going to put this 0.8 over 1. Okay, so putting 0.8 over 1, and remember we put 0.8 versus 80 because when we use percentage in an equation, it's got to be in decimal format. So you've got to move that decimal 2 places to the left. All right, so we put that over 1 and then we cross multiply. We cross multiply. And so I get 18 plus X equals 0.8 times 30 plus X. And then what we have to do here is we are going to take this 8 and distribute it to the 30. And then we're going to distribute it to the X. So when we do that, we get 18 plus X equals 24 plus 0.8X. Now, this is a simple equation we can solve. So, you bring the x's to the left and you bring the constants to the right. So, if I take 1x and I subtract 0.8x, I get 0.2x. And then if I take 18 and subtract that from 24, I get 6. Now, I've got 0.2x equals 6. So, to undo multiplication by 0.2, I'm going to divide by 0.2. And I get that she needs to make 30 free throws to increase her success rate to 80%. Now, if you don't believe me, you can easily go do 18 plus 30, which is 48. 48 over 60, I guarantee you, will be 80%. All right, let's look at our last one.
Okay, our next example says the sum of the reciprocals of two consecutive odd integers is 16 over 63. What are the integers? Well, the first thing we need to define is two consecutive odd integers. Two consecutive odd integers. So we're going to start off by letting x be the first odd integer. And this setup would work even if it said two consecutive even integers. So two consecutive odd, two consecutive even, they're going to be set up the same. So if I let x be the first consecutive odd integer, then how am I going to get to the next odd? You may be thinking x plus 1, but that won't work because remember our numbers are set up odd, even, odd, even. So if we add 1, we're going to be going with an odd and then an even. Okay, so we can't add 1 because that just flips it from odd to even. So we need to add 2 because think about it, 1 is odd, to get to the next odd is 3, so I have to add 2. So my next one's going to be x plus 2. We are now going to look at the word reciprocal, and let's define the word reciprocal. Remember, that means you flip the fractions. Well, both of these are over 1, so my first reciprocal is 1 over x. My next reciprocal is 1 over x plus 2. This now talks about the sum. Well, sum means to add. So when I do 1 over x plus 1 over x plus 2, what is it going to equal? 16 over 63. Okay, now what I'm going to do, there's a couple of different ways to solve this. You can find the LCD of the entire problem and clear the fractions. You can get a common denominator of all three parts and then set the numerators equal. Or you can actually do a common denominator of the left side, combine it into one fraction, and then cross multiply because it's a proportion. I think that's what we're going to do. So let's go with the LCD of x and x plus 2. Now, if you'd rather solve it by clearing the fractions or getting a common denominator across the whole problem, you can do that. I just thought for my sake, it might be easier to squish the left together and cross multiply. So for 1 over x, I'm missing x plus 2. So I'm going to do x plus 2 over x plus 2. For 1 over x plus 2, I'm missing x. So I'm going to multiply it by x over x. And then I'm going to leave 16 over 63 alone because, again, I'm setting up a proportion. I'm squishing the left together to make one fraction, then I'm going to cross multiply. So I end up with x plus 2 over x times x plus 2 plus x over x times x plus 2 equals 16 over 63. We're now going to combine those like terms and get 2x plus 2. Okay, now I'm ready to cross multiply. So I get 63 times 2x plus 2 and 16x times x plus 2. So let's distribute the 63 and the 16x. So I end up with 126x plus 126 equals 16x squared plus 32x. So I bring everything over to the x squared side, so I subtract 126x from both sides as well as 126. Now I'm ready to factor. So first thing I notice is that I can factor out a 2. Hopefully that makes my numbers a little bit more manageable. Okay, so if I can factor out a 2, that's a lot easier to deal with than 16, 94, and 126. So I factored out a GCF. Now I'm going to factor the inside. So I get 0 equals 2 times x minus 7 times 8x plus 9. I'm now going to set each piece equal to 0. Well, 0 will never equal 2. Then I say, okay, well, 0 equals x minus 7, so x is 7. And then 0 equals 8x plus 9, which gives me negative 9/8. Now, you may be wondering, well, why can't negative 9/8 work? Because right here is where I got x is 7, and then here I got x is equal to 9/8. And you're like, well, why can't we use negative 9/8? Look at the key word up here. The key word up there says integers. Negative 9/8 is not an integer. It is a fraction. So that is the reason we cannot use 8x plus 9, which gives us negative 9/8, because it gives us negative 9/8, which is not an integer. So the only integer we can use up here is 7. So that tells me 7 and 9 are my consecutive integers. And you may be wondering, well, wait a minute, how did you get that? Okay, so I know x was 7. And then I took x and plugged it into x plus 2. So 7 plus 2 is 9. And you can always try that. So if you can do 1 over 7 plus 1 over 9, and you combine them, get a common denominator, and then add them, you're going to get 16 over 63. So that is how we tackle the sum of the reciprocals of two consecutive odd integers. Now, let me also tell you that this would be the same process you would use if they said two consecutive even integers. The process will be the same.
Okay, let's look at this problem. They want us to solve for the copyright symbol. So here we are, we have an equation with 3 unknowns. How do we go about solving for that copyright symbol? Well, the first thing you need to do is you need to get the term that has that copyright symbol. You need to get it isolated, get it completely by itself. So to do that, we are going to have to subtract 1 over x from both sides. The next thing we're going to have to do is we are going to have to get a common denominator on the right side. We are going to get a common denominator on the right side. We're not messing with the left side any. We're just going to get a common denominator on the right side. And that common denominator would be x times y. So, looking on the right, 1 over y, he's missing that x in the denominator. So I'm going to multiply top and bottom by x. Then 1 over x is missing the y. So I'm going to multiply by y over y. Now we're going to simplify. That becomes 1 over the copyright symbol equals x minus y over xy. Now, we have a really cool property in proportions, because that's essentially what this is, two fractions that equal. We've got a really cool property in proportions that says I can flip one side as long as I flip the other side at the same time. Because what we really want, we don't want 1 over c, we want c over 1. So if I flip the left, then I have to flip the right as well. Like so, the reciprocal property. So now you don't want to cross multiply because c over 1 is simply c. So we are going to say that c equals xy over x minus y. So you'll have a couple of these, 3 or 4 on your homework, and then you might see it again. I'm just saying, study, study, study. All right, let's look at another one. All right, let's look at a different kind of application problem. This is a distance equals rate times time problem. So let's read it and see what they want us to do. It says a passenger train travels 392 miles in the same time that it takes a freight train to travel 322 miles. If the passenger train travels 20 miles per hour faster than the freight train, find the speed of each train. So, we know we have this equation. If distance equals rate times time, then time equals distance divided by rate. All right? So, when you're doing these problems, the first thing you want to do is you want to set up a table. The first column of your table will be what you're dealing with, train type, upwind, downwind, against the current, that kind of stuff. That's going to be your first column. Your second column is going to be distance. Your third column is going to be rate. And your fourth column is going to be time. So let's look at the train types. So we have two train types. We have a passenger and we have a freight. Now, the passenger train travels 392 miles in the same time that it takes the freight train to travel 322. So passenger is 392. Now, it says in terms of its rate, the passenger train travels 20 miles per hour faster than the freight train. Faster than, well, do we know how fast the freight train is going? No, but we can let it be X. Okay, so the freight train's rate can be X because we don't know how fast it's going, but we do know that the passenger train is 20 miles per hour faster. So that's going to be X plus 20 because we don't know how fast the freight train's going. Now, using this handy dandy little equation we came up with, we can use that to find time. Okay, now we don't know time. The only thing we know about time is that this occurs in the same time. It occurs in the same time. But other than that, we don't know the time. So I can use time equals distance divided by rate. And I can take 392 over, divided by, if you will, X plus 20. And that gives us our expression for time. Freight train. It travels 322 miles. Well, how fast? Well, we don't know. That's why it's got to be X, because we don't know. Now, to come up with the time, we have to take distance divided by rate, because we don't know the time. So we come up with that expression. Now, again, you're like, well, I don't know what I'm supposed to do. Okay, same time means it takes the same amount of time. So the time of the passenger is going to be equal to the time of the freight. So we're going to set our two times equal to each other. So we're going to do 392 over X plus 20 equals 322 over X. So now we are going to cross multiply. Because all it is the proportion, y'all. We're going to cross multiply. So I get 392x equals 322 times x plus 20. All right, so now we distribute 322 to x plus 20. And we come up with 392x equals 322x plus 6,440. Now we solve for x. This is an algebra 1 equation at this point. So we bring 322x over to the other side, and then we set it equal to 6,440, and we get x is 92. Now that's awesome. That's the speed of one of the trains, right? X represents the speed of the freight train. So we know the freight train's going 92 miles per hour. But how do we find the passenger train? Passenger train is x plus 20. What is x plus 20? 92 plus 20. And that comes up with 112 miles per hour. So you found the speed of each train. Let's move on. Okay, last example. Same type of problem, different scenario. Mary can run 5 miles downwind. That's with the wind at her back. So downwind is the wind at her back. It's pushing her along. In the same time that it takes her to run 3 miles upwind. That means she's running into the wind. So it's kind of pushing on her and slowing down. And Mary's natural speed is 6 miles per hour. But her natural speed is really, if there were no wind, that's how fast she runs. Okay? Find Mary's running rate for both downwind and upwind. So, got to make our table. Again, we're still going to use time is distance over rate. So here's our table. Now, instead of it being type of train, it's the wind. So we know that she's going downwind. That's with the wind at her back. It's pushing her along, kind of speeding her up. And then we have upwind, which is against the wind, meaning it's pushing against her and providing some resistance, and it's slowing her down. So downwind, her distance is 5 miles. Okay? Her rate, so let's think about this. Her rate downwind is going to be faster than her natural rate. So we're going to say it's going to be 6 plus the wind, because it's going to be faster than her natural speed, because it's kind of giving her a little, a boost. It's kind of speeding her up. So it's her natural speed plus the wind. Now, we don't know the time. All we know is that it is the same time. That it's the same time. Okay, so that's all we know. So we don't know really anything about the time except downwind is equal to upwind. Okay, so I'm going to use my little equation here that time equals distance over rate. So I'm going to say 5 over 6 plus W. Now, upwind. Upwind, she can only run 3 miles. But the wind is slowing her down. So it's going to slow down her natural speed. So that indicates subtraction. So it's her natural speed minus the wind because it's slowing her down. Now to find her time, we do the same thing. 3 over 6 minus W, distance divided by rate. Okay? So, again, the main thing we know here is that this is occurring at the same time. So, same time, that means times are equal. So, I'm going to set my times equal. So, I have 5 over 6 plus W, and 3 over 6 minus W. So now it's just a proportion. We cross multiply and solve. So that gets me, now I apologize, I reversed it. This I put on the left. I don't know why, it just happened when I typed it. But, so 3 times 6 plus W gives me 18 plus 3W, and then 5 times 6 minus W gives me 30 minus 5W. Now we are going to solve. So the first thing I'm going to do is I'm going to add 5W and subtract 18. So if I add 5W, that gets me 8. And then if I subtract 18, that gets me 12. So I end up doing 12 divided by 8. And I get 1.5. So you can do that. When you solve for W, you get 1.5. But the question said, find her running rate for both downwind and upwind. Okay, so in this case, X is representing, or excuse me, not X, W. W is representing the speed of the wind. So to find her downwind and upwind, we've got to plug that into the rate equation. So 6 minus 1.5 is 4.5. 6 plus 1.5 is 7.5. All right, so there's my 2 rates, and we're done. All right, so really, they look scarier than they are. Those problems are not bad at all. Okay, and for our
All right, that concludes it for today's lesson. We are done. This was the last of Unit 6. Woohoo! We are done. All right, so like I said, now you may go start on your Unit 6.6, your Day 6.6 homework. All right, we'll have a review day here in a couple of days to review everything we've covered in Unit 6, but that's it for today. So guys, go out there, have a great day, make good decisions, social distance of 6 feet, wash those hands, wear your masks, and make great, awesome decisions. And have a wonderful day. We will talk to you soon. Bye-bye.